Alright, as we move on in the Pathfinding video series, the next topic we need to address is a little bit of simple project setup. We need to add some assets to the project, and there are a few code enhancements and corrections that need to be made in the behavior project before we can advance into the pathfinding section. So, beginning with the first, we have a few new texture assets that need to be added in. Currently inside of the project, under Content, you can see we have only one texture asset, and that is the arrow texture that is being used for all actors. Now, as we draw various elements of the pathfinding scenario, we're going to create debug information so we can see exactly what the algorithm is doing. Now, some of these elements will be represented by textures. And over here in a folder, I have created a handful of new textures which will be used to create just such debug information. Now, in an upcoming video, we'll get into exactly what each of these textures represent. So for the time being, all I'm going to do is grab all three of them and drag them over into the content project inside of Visual Studio. So just getting these ready for use when we need to grab them. Now, in addition to some textures, we're also going to need some fonts that will allow us to read out various forms of numeric information. So, once again inside of content, we're going to add some new items, and these are going to be sprite font items. The first one is going to be named Font Large. And we'll hit add for this new sprite font. Now for the font itself, we're going to set up its font face and size, as well as its style. For the font here, we're going to use the Miramonte font. Now for the size of the large font, I'm actually going to leave that at a size of 14, and I'm going to change the style to bold. Now that should all we need to do for the large font. So before we build these fonts, I'm going to add the second one. So I'm going to first jump over to Content, once again add a new item. This new item is going to be our second font, and it will be called Font Small. So we'll get this dropped in. Once again, we're going to use the Miramonte font. We are going to change the size of the font to a size of 8, and we are going to set the style to bold. Alright, with both of these fonts set up, I'm going to hit F6 to make sure that the definition files get saved out and the new files get built into the appropriate textures. Now with both of these set up, I'm also going to close them out of our code window here just to conserve space for our various code files. Alright, so moving on, the next element of project setup we need to address is a scene for our new navigation system. So, up to now, we've built exactly one scene. We built a behavior test scene to encapsulate the current scene in the behavior demo. Now we need to create a new scene to house all of the things that are going to live in the demonstration project that is going to go along with pathfinding navigation. So we'll do this by creating a new class called Scene Navigation. We'll do that over here inside of the Solution Explorer. I'm going to collapse up our content project and add a new class to the behavior demo project. This class is going to be called Scene Navigation. So we'll hit add and let it build the new class. Now, with this class, we're going to need to put together a few using statements, just like we did in the behavior test. We'll need the same XNA.framework, XNA graphics, and content. So I could very briefly jump over into an existing scene. I'll actually jump all the way to the base scene. And I'll grab the using statements currently in that scene. We'll paste all of these into our navigation scene, and that gets all the types set up and ready for use. We can then look at the scene navigation class itself and make sure that it extends scene. Now, inside of the scene navigation class, we'll begin with our overrides to our three methods, our build scene, update, and draw. So we'll drop all of these in first, leaving them essentially as skeleton methods. And as we go, we'll also pull out the call to base for each of these methods. So we have an override for build scene, an override for update, and an override for draw. Now here in these methods, there are a few things that we can get set up before we move on, since the principle of these demo scenes have all based around the actor model, where we have a scene filled with actors. We can get that set up for update and draw. Since we know that we have an actor list over in the actor class, we always want to update and draw that. We can go ahead and drop that code in place here in the scene. So beginning in update, we will put together a for each loop, and we will loop over the variable name actor. So for each actor in all of the actors, which is of course found inside the actor class, listed as the actors list. Then inside of the loop, we can jump up and add a simple call to actor.update. And our update on actor doesn't need any parameters, so we'll finish off the call to actor update. And that'll take care of our updating. If we wanted to, we could jump in here and collapse this a little bit, take out our braces, since we're only going to have a single statement inside of the call. Now inside of draw, we of course want to draw all of our actors, but we also need to set up the call to graphicsDevice.clear and our sprite batch. Now this code is going to be very similar to the current scene, so I'm actually going to begin with the scene behavior test and copy all of its drawing code. So we'll simply copy all of this over to our navigation scene. And with this code, everything is looking good except for the background color. Because of the colors that we will be using as we demonstrate all of the pathing code, all of these colors have been designed to work on a black background. So we're actually going to change the background color for this scene to a color of black. And I'll simply zero out all of our color components to accomplish that. So with that, now we have all of our overrides are set up inside of the scene, so we are ready to tell our game about the new navigation scene. Of course, over here in Game 1, we're still building a scene behavior test. So I'm going to pull that out. We can hit Control-K-W, bring up our word selection. We can see we now have scene navigation as a valid class we can create and instantiate. And if we were to change this to a scene navigation and run the game, we are now presented with a blank black screen, which again, this is the intended background for our new pathfinding demonstration. Now one last thing I want to do is I want to make the mouse visible, since we're going to be using some mouse-based control as we work with this scene. And on the recorded video, generally you can see the mouse over the scene, but of course when working with an XNA game, actually working with it on your machine, you'll notice that XNA will generally hide the mouse as it goes over the gameplay area. Again, due to the recording scenario, this is generally visible on the video, but of course when you're working in a scene, you will want this to be visible. So we can set this very quickly from inside of our game's constructor. We can say this dot is mouse visible will be set to true. And now on our end, we can see the mouse in front of the game, and as you follow along, that will allow you to see the mouse and use it for mouse-based interaction. Alright, with this, we have our new scene set up and ready for use, but before we progress into more of the pathfinding code, there are a few changes and corrections to be made in the behavior scene. The first of which is the actor class. I'm going to bring up our actor.cs code file, and there's two things we need to do inside of the actor class. A lot of things that we create are going to be based on radius for things like selection and drawing. So inside of the actor class, we're going to add a new field called radius, just to make it available, since we're going to be basing all of our objects from the actor class. We need to make sure that this field is available to us for the code later in this demonstration. So I'm going to place a public field. This will be a float, which we're going to call radius. Now we are also going to make sure that radius gets initialized as soon as the texture is set. So if we scroll down, we can see that here inside of actor's constructor, we are actually feeding in a texture and using that to set things like the origin. We're going to use the texture. You could think of this kind of like default mode, where we'll use the texture to drive the size of the origin. And the advantage to this is that if we use circular textures with our actors, then they will all automatically get an appropriate radius whenever we send in a circle-based texture. So what we'll do here is we'll set this dot radius to be equal to this dot origin. And again, if we're assuming that this is to aid with circle setup, it doesn't matter if we grab x or y because they should be equal. So we will simply grab x. All right. Now, once again, since actor is meant to be the base class of other actors that we will create, we are going to need to be able to override some of the methods, some of the functionality. So we can begin with our update and draw methods. We will specifically need draw, so I'll hit this one first. All we're going to do is add the virtual modifier to these methods. In this demonstration, we shouldn't need the update method, but just to follow this practice of actor being a base class, I'm going to go ahead and drop it in, because it is very likely that you would want to override update on a given actor. So we have update and draw are both set to virtual. In addition to both of these, I'm going to add a new virtual method called delete. Up till now, if we had wanted to remove an actor, we would simply look at the actors list, currently defined here, and simply remove things from the list, because the list is really the only thing that counts as our actor scene. Everything is going to live inside of the actors list. So right now, we could very easily remove things from that list, and they would go away. Now, in descending classes, or a descending class that we're going to create, we will need more control over this process. We'll need to know when a deletion happens because there will be additional things to clean up. So we're going to standardize the procedure of deleting actors by making a delete method. So we'll make a method that is public and virtual. We will have a void return type, and we will call the method delete. Now inside of delete, in the actor class, again, we're simply going to drop in the code necessary to remove the actor from the list. So all we will do is we'll take actors, we will call the remove method, passing in the this reference. So again, this is being implemented all the way back at actor just to standardize the procedure of removing actors. Alright, with these changes in place, that should be all we need to take care of inside of the actor class. Actor has now been enhanced to take care of everything we need it to. Now there's one last thing to address. If you remember in the past video set, when we had first created the behavior demo, you noticed at the end of one of the videos there was an interesting bug where all of the actors disappeared mysteriously. And what had happened is we were using vector math to set our directions, and we ran into a scenario where two actors were directly on top of each other, resulting in a vector with a length of 0, and we tried to normalize that vector. That would, of course, result in a floating point, not a number value. We're going to correct this by making sure that we check the vectors before normalizing to make sure that we never set the vector values incorrectly. So what we'll do is we'll jump over here into our behavior file, and inside of behavior there are two checks inside of this file that use vector normalization. If we scroll down near the bottom, we can see generally things that have to do with a target direction. That direction gets normalized so that it can be applied appropriately with the weight. Now in order to make these easier to find, I'm simply going to use find inside of Visual Studio. And that way I don't have to worry about missing any of them. So looking for what we're going to be looking in, I'm going to change this. Actually, rather, I'm going to leave it current document and change it to normalize. So we can see the first change is going to need to be inside of the behavior seek. Of course, again, we're taking a target position minus an actor position, and technically those could be located directly on top of each other, resulting in a target direction with a length of 0. And we want to check that before we normalize it. So we'll jump in here and place an if statement saying if target direction is not equal to vector2.0, then we will proceed with the normalization. If it is equal to 0, then we'll end up adding nothing to direction because we'll multiply 0 against the weight, and we simply won't affect the direction, which is much more desirable compared to having all of our actors disappear because they're at an undrawable location. Alright, since we had last searched for normalize, I'm going to hit F3 to jump down to the second occurrence of normalize, which is located inside of the behavior avoid class. So once again, before we perform a normalization, we're going to do a check saying if target direction is not equal to vector2 dot 0, then and only then proceed with the normalization. Now, with those two checks, those are the only two places inside of behavior that are using normalize, so I'll make sure that this code file gets saved out. Now, one last place that normalize appears is inside of actor. So looking at actor, if we scroll down to update, you can see that in this case we did put a check in place, or we're checking length before we normalize. But there's one slight adjustment I want to make to this, since we're doing a little bit of unnecessary math, where length is going to need to take the two distances and find their square and gain the square root of that value. Those are unnecessary mathematical steps that length is going to be using. It'd be a lot more efficient just to check the direction against 0 and proceed only if it's not 0. So just like we did inside of the behavior class, we'll say if this dot direction is not equal to vector2 dot 0, then we'll proceed and normalize this dot direction. So again, just making that slightly more efficient. Alright, with these changes in place, I'm going to build one last time. Of course, there's nothing in the scene, so if we run, we have a nice blank screen where we have set up for our scene navigation. But what we've got accomplished are the basics of the scene setup so that we can progress into path node navigation. We got all of our assets, our textures, and our fonts, and we have made some enhancements to actor as well as some corrections to the vector normalization. So with all these pieces in place, that will wrap up this video.